Okay, so here's example one. I'm going to go through this. It's a little bit involved, but again, just bear with me. But we're going to set up this idea of taking matrix multiplication as a composition of maps. Okay, so the first thing we look at is looking at the two maps here. So it says let H be a map from R4 to R2 and G be a map from R2 to R3. And then we're going to fix the bases. The base is going to be contained in R4, base B, and then C is going to be contained in R2, right? So that's going to be over here. And then D is contained in R3. So those are going to be the three bases that we're going to refer to, that we're going to fix. And then let these be the representations that we're looking at, okay? So here's the representation H matrix for H. So this is the matrix representation for going from B to C. So this is the mapping. And then for G, this is the representation from C to D, right? For G. Okay? So these are the representations that we're going to use. Okay, now, to represent the composition of G and H, so going from 4, right, to 3. So we're going to go 4 to 3. We start with a vector V, and then we're going to represent H of V, and then we're going to represent G of that. So now the representation of H of V, first of all, we have V, right? We have to have our vector V. And then we're going to write the representation of H of V is going to be the product of H's matrix, right here, by the vector V. Okay? And so the representation with respect to C of H of V is going to be this multiplication. Notice that again, we're taking each of these multiplied by each vector component. So 4 times V1 plus 6 times V2. So we're going down this column as we go across this row. And so we're adding those. So adding those products. So 4 times V1 plus 6 times V2 plus 8 times V3 plus 2 times V4. And so we get that first entry. Okay? Then we do the same thing with the next row. So we get 5 times V1, 7 times V2, 9 times V3, 3 times V4. We're adding those together. And we get the second entry. Okay? And notice that the dimensions match here. Okay? This is a 2 by 4. This is a 4 by 1. Okay? And we end up with a what? Look at that. We end up with a 2 by 2. Or excuse me, I'm sorry. Not 2 by 2. That's 2 by 1. So keep that in mind. So we end up with the 2 by 1. Now, so this is now the representation with respect to C. Okay? That's the representation of this mapping, H of V, with respect to C. Now what we're going to do is we're going to get the representation with respect of D of the composition of G of H of V. So now this is where the last step is. Okay, so now, well, we already know this, the representation here. Now we want the representation of G of H of V. And so it's going to be the product of G's matrix, which is right here, with the vector h of v, which is what we got right here. And so now the representation with respect to D of G of H of V is now going to be, again, G times, again, from C to D, of this vector. Now, let me erase this because, again, we're going to take our time, make sure we're doing this correctly, because, again, what I'm going to do is I'm going to go down this column across each row. So let me rewrite this. So from C to D of G, oops. Okay, so that's going to equal, now all I'm going to do is I'm going to take this and multiply across the top row. So it's, in this case, it's going to be what? How do I want to do this? Okay, so I'm going to go 1 times this whole thing. So that's just going to give me 4v1, 6v2, 8v3, plus 2v4. And of course, plus 1 times this one, so it'll be 5v1 plus 7v2 plus 9v3 plus 3. V4, okay? Now I'm going to do the same thing here. Now I've done the first row with the column. Now I'm going to go down to the second row, do the same thing. So it's going to be 0 times this one, which is just going to give me 0, plus 1 times the bottom row. So that's just going to give me 5v1 plus 7v2 plus 9v3 plus 3v4. And so now we're done with that one. And the bottom one is going to be 1 times the first one plus 0 times the second one. So the second one's just going to go to the way. So the third entry is just going to be 4v1 plus 6v2 plus 8v3 plus 2v4. And notice that we have a 3x1 matrix. You know what? Let me do this just to make it clearer. I think it's, let me do this. So this is going to be 1 times that, 1 times that, and then this is going to be 0 times this. So again, just, and then plus 1 times this. Okay, and then the last one's going to be 1 times this plus 0 times that. Okay, so without just writing it out all the time. Now I'm going to simplify this. And by rearranging some things, oh, how do I want to write that? Yeah, let's just do this. So I'm going to rewrite it this way. What I'm going to do is I'm just going to regroup these. So this is going to be 1 times 4. So it's going to be 1 times 4 plus 1 times 5 times V1 plus, now I'm going to do 1 times 6 plus 1 times 7, and then plus 1 times 6 plus 1 times 9 times V3 plus the quantity 1 times 2 plus 1 times 3 times the quantity V4. Okay, so that's that. So I just regrouped them. Now I'm going to do the same for the next one. And so that's going to give me 0 times 4 plus 1 times 5 times V1. Is that right? Yes. And then plus 0 times 6 plus 1 times 7 times V2 plus 0 times 8 plus 1 times 9 V3 plus 0 times 2 plus 1 times 3 times V4. And then similarly, the bottom one is going to be 1 times 4 plus 0 times 5 times V1 plus 1 times 6 plus 0 times 7 times V2 plus 1 times 8 plus 0 times 9 times V3 plus 1 times 2 plus 0 times 3 V4. Okay. And so now, what does this tell us? This gives us the representation of the composition of the maps. Oh, by the way, this is with respect to D. And so this is the matrix vector product. Or it gives us this matrix vector product, which now I've got the V1, V2. Now I'm going to undo the matrix multiplication now like this. Because now it's well, let me just write it out. So it'll be let me see here. It's going to be so it's going to be 1 times 4 plus 1 times 5 1 times 6 plus 1 times, oops, times 7, and then 1 times 8 plus 1 times 9, and then it's going to be 1 times 2 plus 1 times 3. And then the next row is going to be 0 times 4 plus 1 times 5. And then the next entry is going to be 0 times 6 plus 1 times 7. And 0 times 8 plus 1 times 9. And then this is going to be 0 times 2 plus 1 times 3. And then finally the last row is going to be 1 times 4 plus 0 times 5. And this is going to be 1 times 6 plus 0 times 7. And this is going to be 1 times 8 plus 0 times 9. And finally we get 1 times 2 plus 0 times 3. That's going to be that matrix, and of course it's going to be multiplied by V1, V2, V3, and V4. And so the matrix representing G circle H has the rows of G combined with the columns of H. Oh, let's make sure we get the notation right. So this is going to be B comma D, and this is, oh, hold on, not B, this is B, because we're coming from the domain. All right. Now we're going to introduce a definition and do some examples.